So the problem on your screen says to use polar coordinates to find the volume of the solid region bounded above by the hemisphere z equals square root of 16 minus x squared minus y squared, and bounded below by the circular region given by x squared plus y squared less than or equal to 4. So we're talking about the circle x squared plus y squared equals 4 in the xy plane. That's the circle of radius 2, centered at the origin. Because it says less than or equal to 4, this is our region of integration, and over that we have the function square root of 16 minus x squared minus y squared, which just gives us the upper half of a sphere sitting in the xy plane. All right, so this would be 2 and 2 on my x and y. We have the upper hemisphere sitting on top of that circle. So that's the function we want to integrate. And clearly it's going to be easier if we translate to polar coordinates, because the shapes that we have, the circle and the sphere, those are exactly what polar coordinates are all about. All right, so let's first change our function in terms of theta and r. So we will have square root of, sorry about that. We'll have square root of 16 minus x is r cosine theta, so that's going to be r, and minus r squared sine squared theta. And when I factor out r squared, I get 16 minus r squared. And what's inside is sine squared theta plus cosine squared theta, which of course is 1. So it's just 16 minus r squared. And that's nice. It's nicer than 16 minus x squared minus y squared. So that's the function I'm going to be integrating. And we already said that our region of integration is here. So in this region, it looks like my angle theta is running between 0 and 2 pi. And my radius r is running between 0 and 2. So I'd like to set up the integration as integration 0 to 2 pi, the full circle, 0 to 2, my function, square root of 16 minus r squared, and then remember I get r from my Jacobian, r dr d theta. And having that r is actually quite nice because it lets me have a nice u substitution. I'm just going to say let u equal 16 minus r squared, then du is minus 2r dr. And clearly I don't have minus 2r dr, I have just r dr, so I'll put minus 1/2 out front. I also need to change my bounds from r to u. So if r is between 0 and 2, then u should be between 16 minus 0 and 16 minus 2 squared. So from 16 to 12, square root of u, du, d theta. And because integration from 16 to 12 looks a little strange, I'm going to say this is 1/2 times integration 0 to 2 pi times negative integration 16 to 12. And I know that I can rewrite by changing the sign from negative to positive, I get to switch my bounds. So I get to say 12 to 16. All right, now this doesn't look bad. So I'll keep 1/2 outside. Take the antiderivative of u to the 1/2. I get 2/3 u to the 3/2. I want to evaluate between 12 and 16 before integrating with respect to theta. So let me pull 2/3 out. 2/3 times 1/2 is 1/3. And I'll have 16 to the power 3/2, which I'm going to write as 1/2 cubed, minus 12 to the power 3/2, which I'm also going to write as 1/2 cubed. That's what I'll be integrating with respect to theta. Now 16 has a nice square root 4, and 4 cubed is 64. But 12 is not so nice, but I know I can think of 12 as 3 times 4. So square root of 12 is square root of 3 times 4. That's square root of 3 times square root of 4, or 2 square root of 3. Then when I cube that, 2 square root of 3 cubed is equal to 2 cubed times square root of 3 cubed, and that's 8 times 3 times square root of 3. So that's what I'll use here. I'll say this is 24 square root of 3. But that's also just a constant. So why don't we pull it out and say this is 64/3 minus 24 square root of 3/3 times integration d theta is theta, and I'll evaluate between 0 and 2 pi, which of course is just 2 pi. Let's see if we can simplify here a little bit. 64/3 should be, I think we're a little bit stuck with that. But what I can do is pull out 16. Let me go back and check my work here. Right. I'm going to multiply by the 2 pi. I apologize. So this is really going to be 128 pi/3 minus 48 square root of 3 pi/3. And that's where I'm able to take out the 16. So 16 pi/3 can come out. And I'm going to have 8, because 8 times 16 gives me 128, minus 3 square root of 3. So that's probably about as nice as I can get my answer to look. Let's go back and read the instructions of the problem one more time. It told us that we were going to get 16 pi over a, so I got 16 pi/3. Times b was 8, c was 3, and d was 3. That was the answer that I got. So it tells us we want to add a, b, c, and d. So if I let a equals 3, b equals 8, c equals 3, and d equals 3, then a plus b plus c plus d is 17. I can answer the question that way.